Hello everyone. Radical expressions and functions. In this section, we consider roots such as square roots and cube roots. We define, symbolize, and consider methods of manipulating symbols to get equivalent expressions. Square roots and square root function. When we raise a number to the second power, we say that we have squared the number. Sometimes you may need to find the number that was squared. We call this process finding a square root of a number. The number c is a square root of a if c squared equal to a. For example, 5 is a square root of 25 because 5 squared equal to 5 times 5 equal to 25. The same as 5, negative 5. Negative 5 is a square root of 25 because negative 5 all to the power of 2 means negative 5 times negative 5 is equal to 25. So 25 has two square roots such as 5 and negative 5. But what about negative 4? Does it have a real number square root? No. Why? Because there is no number such as c such that c squared is equal to negative 4. So negative 4 does not have a real number square root. Properties of square roots. Every positive real number has two real number square root. The number 0 has just one square root, 0 itself. Negative numbers don't have real number square roots. Example 1. Find the two square roots of 64. So we need to determine what are numbers. When I squared them, I get 64. So the square roots of 64 are 8 and negative 8. Why? Because 8 squared equal to 8 times 8 equal to 64. Negative 8 squared means negative 8 times negative 8 equal to square 64. Your turn. Find the square roots of 36. Principal square root. The principal square root of a non-negative number is its non-negative square root. Because I said before, any positive number has two square roots. One is positive and the other is negative. So the principal square root is non-negative square root. The symbol radical A represents the principal square root of A. So to the name negative square root of A, we can write negative radical A. For example, simplify. Here, this is not the square root, it's called principal square root. That means we need only the positive square root of 25, so it's 5. What about this one? Negative radical 25. So here, we need the negative square root, so it's a negative 5. What about radical 81 over 64? So here we can distribute the radical here, or we can write 81 over 64 as 9 over 8 all to the power of 2. So equal to 9 over 8. What about negative square root of 0.0049? So here we can rewrite it again as 49 over 10,000. That means negative square root. 49 means 7 squared, and 10,000 mean 100 squared. So here it will be negative 7 over 100 equal to negative 0.07. What about radical 0 is 0? Okay, what about radical negative 25? So this does not exist. Okay, your turn. Simplify. Radical 81 over 100, radical 0.0064, negative radical 25 over 64, radical 1.44. Radicals, radical expression, and radicand. This simple is called a radical. An expression written with a radical is called radical expression. The expression written under the radical is called radicand. For example, when I write radical A, so this expression is called radical expression, and A here is called radicand. So if I asked you to identify the radicand in x radical x squared minus 9, so the radicand is the expression inside the radical, so this is called radicand. Your turn. Identify the radicand. For the given function, find the indicated function values. G of x equal radical 6x plus 4. Find g of 0, g of 3, and g of negative 5. So g of 0, that means we have to replace x by 0. So we have to replace each x inside this expression by 0. So we have only one x, so we can replace x here by 0. So 6 times 0 is 0, 0 plus 4 is 4, and we know that radical 4 is 2. What about g of 3? G of 3, here we have to replace x by 3. 6 times 3 is 18. 18 plus 4 is 22. Radical 22. We don't have exact integer to find radical, so we can use calculator if you want to find it. What about g of negative 5? So we have to replace x by negative 5. 6 times negative 5 is negative 30. And we know that negative 30 plus 4 is negative 26. We know that negative 26 is a negative number. So if we have negative radicand, that means no real number function value exists. Your turn. If f of x equal negative radical x, find f of 4, f of 7, and f of negative 3. How to graph radical function? Graph g of x equal radical x plus 2. So as we know, the easiest way to graph any function is to make a table. So let us make a table. So here x, g of x, let us take values for x equal negative 2. We can start here from negative 2 because negative 2 plus 2 is 0. We couldn't use negative 3 because negative 3 plus 2 is negative 1, and there is no real number as a square root of negative 1. So here we start with negative 2, negative 1, 0, 1, 2, 3, 5, as you like. Choose any values as you like. Use your calculator to find the value of the function. So radical negative 2 plus 2 means radical negative 2 plus 2 equal radical 0, so equal to 0. The same as negative 1, radical negative 1 plus 2 is 1, 0 is radical 2, and we know that radical 2 using calculator approximately equal 1.4. 1 means radical 3 approximately equal to 2.2. 2 means square root of 4 is equal to 2, and then 3 square root of 5. So again here radical 3 is 1.4, and here radical 7 equal to 2.6. Okay, let us start to plot the points on the coordinate plane. Here we have x-axis and here we have y-axis. The first point is negative 2, 0. So here this is the first point. Negative 2, 0. What about negative 1? Negative 1, 1, 0, square root of negative 2 approximately here. 1, 1.4, 3, 2 is 2, 3 is 2.2, 5 is 2.6, and we can continue. Then we can graph the curve. So this is the graph of the function. Your turn. Principal square root of a square. For any real number a, square root of a square is absolute value of a. The principal non-negative. So square root of a square is absolute value of a. Like when I say square root of 25 means square root of 5 square, that means absolute value of 5, and we know that absolute value of non-negative the same as the number. But if I have here absolute value of negative 5 squared, so here the answer must be absolute value of negative 5. So what is absolute value of negative 5 is 5. So if I have here absolute value of 4x squared, so first step I have to rewrite 4x squared as 2x all squared. Now square root of 2x all squared is absolute value of 2x. That means absolute value of 2 is 2, but absolute value of x is absolute value of x. Why? Because I don't know x is a positive value or a negative value, so I have to keep absolute value. Your turn. Find each of the following: square root of y squared, square root of negative 24 squared, square root of 4 times x plus 1 squared. Cube roots. The number c is the cube root of a, written as third root of a. Here the index represent cube root. Index here 3. If the third power of c is a, that is, if c to the power of 3 equal to a, then cubic root of a is c. So 2 is the cube root of 8, because 2 to the power of 3 means 2 times 2 times 2 equal to 8. Negative 4 is the cube root of negative 64, because negative 4 to the power of 3 means negative 4 times negative 4 times negative 4. Negative times negative is positive, positive times negative is negative, so don't forget the sign rule here. Negative times negative is positive, negative times positive is negative. That means every real number has exactly one cube root, only one cube root. So find the cube root of negative 27. So I need to find number. If I cubed it, I'll get negative 27. So we know that it will be here negative 3, because negative 3 to the power of 3 is negative 27. So the cubic root of negative 27 is negative 3. What about cube root of x to the power of 3? Cube root of x to the power of 3 is x. This is not the same as square root, principal square root, because principal square root is always positive, but here cube root maybe it's positive or negative, so I can keep it as x. Cube root of negative 8y to the power of 3, so I can rewrite this expression again as negative 2y all to the power of 3. The index of root is 3 here, so it will be negative 2y. Your turn. Find each of the following: cube root of negative 64, cube root of 27y to the power of 3, odd and even case roots. if the index here is k for a to the power of k. So k here is a variable. That means k maybe it's odd or even. Odd like 1, 3, odd like third root, fifth root, seventh root, and so on. Even square root, fourth root, sixth root, and so on. If k is an odd natural number, then for any real number a, kth root of a to the power of k equal to a directly. But if it even, so kth root of a to the power of k, we must use absolute value. For example, but fourth root of 16 x to the power of 4, let us rewrite the expression again. We know that 16 means 2 to the power of 4, so here we have 2x all to the power of 4. Now 4 here is even, so we have to use absolute value. So it will be absolute value of 2x. We know that absolute value of 2 is 2, but absolute value of x is absolute value of x. Another example. Sixth root of x to the power of 12. So we can rewrite this expression again as sixth root of x to the power of 2 all to the power of 6, because the index here is 6. And we know that the index here is even, so we have to use absolute value. So it will be absolute value of x square. But we know that x square is always non-negative number. X square is always non-negative number. So absolute value of non-negative number is the same number, so it will be x square. So for any real number a, kth root of a to the power of k is absolute value of a. When k is an even natural number, we use absolute value. Don't forget. Kth root of a equal to a when k is an odd natural number greater than 1. So we don't use absolute value here. Your turn. Find each of the following. Seventh root of x to the power of 7 y to the power of 14, and eighth root of x to the power of 8 y to the power of 60. Thank you. Don't forget to like and subscribe here.